Bismillahirrahmanirrahim. Assalamu alaikum dear students. I'm Arif and I welcome the students of PUCIT and all my virtual students around the globe to this new online course titled Computer Organization and Assembly Language Programming. Well, since last 2 years, I was a bit busy in some administrative responsibilities at PUCIT. And now that I'm free, I hope I will continue this journey of designing and teaching new courses like before, inshallah. I would like to take this opportunity to thank all my students who have subscribed my YouTube channel and have liked over 100 videos of mine on 4 different subjects of operating system, system programming, internet working, and C refresher. Dear students, I'm also thankful for your continuous feedback and appreciations, and I'm expecting the same in this course as well, as this will act as a fuel in the completion of this course. This course of computer organization and assembly language programming is a complete revamp of the course already being taught at PUCIT in the second year of BS Computer Science program. The idea of redesigning of this course came to me when I read the book The Elements of Computing Systems by Professor Noam and Shimon, who are also the designers of the NAND to Tetris course. I would like to pay my gratitude to both of them. Thank you, Noam. Thank you, Shimon. And let's get down to work. Dear students, this is the first slide, which will be common for all the lectures of this course, Computer Organization and Assembly Language Programming. In the upper half of the slide, I have tried to describe the first half of the course, in which we will design the complete hardware of a 16-bit computer called Hack Computer, which is actually designed by Noam and Shimon. We will also write some basic assembly programs, write its assembler, convert it to the corresponding machine code, and then execute these programs on the designed hack computer. Similarly, the lower half of this slide describes the post-bit part of the course, in which we will learn the assembly of the all-time famous x86-64 architecture. These 3 boxes show the Hello World C program, its corresponding assembly and machine code for x86 64-bit architecture. Well, dear students, this slide shows the 4 books using which this course has been designed, and the electronic versions of these books are available on our course Bitbucket repository. First half of the course will be covered from the elements of computing system by Noam and Shimon, and introduction to computing system from bits and gates to C and beyond. Similarly, the second half of the course will be covered from these 2 books, x86 64 assembly language programming in Ubuntu, and introduction to 64-bit assembly programming for Linux and OS X. Well, dear students, you can get most of the course related information from my personal website arifpat.me, and you can always email me your course related queries at arif@pucit.edu.pk. Dear students, you can download software tools, codes, and other resources for this course from bitbucket.org, RFPUCIT code repo. This is the repository for this computer organization course. Okay, dear students, have you ever heard of a physical workout class where the instructor did all the exercises while everyone else just watch attentively? Well, the answer will of course be a no. A big no. Our lectures will also be a mental workout class. So, in my lectures, I expect my students to use their own brain, note the concepts using a copy pencil, and implement them on their systems using different tools for a proof of concept. Last but not least, I'm a big believer in communicating. So speak up, ask questions, and participate in the class. Well, at PUCIT, this is a 4 credit hour course with 1 credit hour lab. The lab timings will be communicated to you soon, and I expect that whatever concepts you learn during the lectures, you must practice them by writing and executing different HTL and assembly programs inside the labs. This is the general criteria for evaluation of those students who have registered this course with me at PUCIT. Uh, and of course, these percentages are not carved on stone. Dear students, there will be lots and lots of quizzes, and they can be surprising as well. And of course, there will be no makeup facility for the quizzes. So your best strategy is to play safe, attend every lecture, and do all the reading and programming assignments. Dear students, I always say that it is better to deserve honor and not get it than to get honor and not deserve it. So please, never cheat. My students, never cheat. As far as submission of assignments are concerned, you will get reasonable time for submissions, and I will not accept any late submission. So dear students, best strategy is to play again safe by submitting everything on time. And to play safe in CS 223, follow these 4 rules. Attend every lecture and lab. Understand course material and practice concept on the provided tools. Submit everything on time. And last but not the least, don't cheat. Okay, so dear students, here is the agenda for today's session. First of all, I am going to address the question as why do we need to do a scuba diving and understand the organization and architecture of a computer system? Why do we need to understand the assembly language when we all can write programs in high level languages like C, C++, C Sharp, Java, Python, Swift, Ruby on Rails, and so on, and the list is quite long. After having a brief discussion on this, then I will move on to the course metrics and the pre-mid and post-mid course, uh, which I will be referring as the first half and the second half of the course. Well, dear students, solving a problem on a computer system goes through a series of steps, passing through different layers. It starts from human thought, the mathematical modeling of the problem and its proposed solution, then design of an efficient algorithm, then implementing that on a specific high level language using specific compilers and OS runtimes. Below this, these are the 4 layers shown in blue. These are of our interest in this course, and I will be talking about these in a bit detail in upcoming slides. And these 4 layers are assembly language, machine language, microarchitecture, and logic design. Dear students, in computer science, we normally don't go below the logic design layer. Uh, and these 4 layers, actually deals with the physical design of the silicon chips using transistors, resistors, capacitors, and so on. Okay, so let me talk about 2 recurring themes that will come up again and again in this course. First is the notion of abstraction, and the second is the notion of hardware and software. Uh, let's talk about abstraction first. Dear students, the use of abstraction is all around us. For example, when we get in a taxi and tell the driver, take me to the airport, we are using abstraction. On the contrary, someone may tell the taxi driver, go straight 1.2 kilometer, then make a right turn, go down 500 meter, then take a left, then go straight for another 750, then take a right, and so on. And maybe someone among us may further break down this first instructions, go straight 1.2 kilometer, to instructions like how to use the accelerator of the car, the steering wheel, how to watch out for other vehicles and pedestrians, and so on. So abstraction is a technique for establishing a simpler way for a person to interact with the system, removing the details that are unnecessary for the person to interact effectively with that system. So abstraction is actually a productivity enhancer. You don't need to worry about details until something goes wrong. And of course, when something will go wrong, it becomes very important to understand the components and how they work together. Okay, now let's talk about the notion of hardware and software. Dear students, being computer scientist, whether your inclinations are in the direction of a computer hardware career or maybe a computer software career, you will be much more capable if you master both. This course is about getting you started on the path of mastering both hardware and software. For example, studying data types in a programming language is a software concept. It becomes more clear when you understand the finite word length of a computer, which is a hardware concept. Studying functions in a programming language is a software concept, and it becomes more clear when you understand the function calling conventions for a specific hardware implementation. Studying recursion in a programming language is a software concept, and understanding its memory and time requirements need the clear concept of the underlying hardware. Studying pointers in a programming language is a software concept, and the hardware knowledge of memory layout make you decide as to when pointers should be used and when they should be avoided. Similarly, studying different data structures in a programming language is a software concept, and your knowledge of computer memory will help you better understand what must be done to manipulate the actual structures in memory efficiently. To summarize, dear students, let me say that a computer scientist can design much better solutions when he or she has a mastery of both the worlds. Dear students, every layer in computer science is an abstraction. And depending on which layer you want to live at, you will have different views of the computer. The lowest layer at which we will move in this course is the layer of logic gates. So we will not be interested in as how an AND gate is implemented using a NPN or PNP transistor. We will just be interested in the logic gates and of course their behavior using the truth table. Let me give you another example of abstraction using the example of C compilation process. Well, a C programmer write down a program in a text file named hello.c, creates an executable file and executes the program on a computer system. Another way is that the programmer creates all the intermediate files as well. Let me show you the steps. First of all, performs the pre-processing and generates the pre-processed file hello.i. Then performs the compilation and generates the assembly of the underlying hardware in a file named hello.s. Then performs the assembling to generate the binary file of the underlying hardware in a file named hello.o. Later, the programmer may perform the static or maybe the dynamic linking to generate the binary executable named a.out. And then to execute this program, the loader may link the program with the dynamic library and loads the program in the computer memory in a specific layout. Well, dear students, you might not be knowing what these four programs CPP, CC, YASM, LD, and maybe this loader do with your source files. You might not be knowing what are the actual contents of these intermediate files hello.i, hello.s, hello.o, and this final executable a.out. You might not be knowing when to use a static library and when to use a dynamic library and how to create these libraries of your own. You might not be knowing as how to create an executable for an architecture other than the host computer on which you are working. And you might not be knowing how to write a compiler, assembler, linker, and loader of your own. Well, dear students, the knowledge of all these concepts depends on the abstraction level where you want to live, in the remaining 3 years of your degree program. And in this course of computer organization and assembly language programming, I will make you do scuba diving with me. Let me repeat, I will make you do scuba diving with me in the deep ocean of computer science. And don't worry, I will always carry spare oxygen tanks with me. Enough of introduction to the course. Let's talk about the contents of the pre-MIT course, whose objective or target is to design and write HDL for a complete 16-bit computer, design its machine and assembly language, and finally write an assembler using C programming language. Well, this slide shows the top-down stack of computer science. At the very top, we have the human thought, which includes the domain of theoretical computer science, covering problem definitions, its mathematical modeling, and algorithm development. And moving down the stack this way, at the very bottom over here, we have an electronic board containing different IC chips. Well, dear students, we will move bottom up in this course. We will not deal with the lowest layer, this layer, as it falls in the domain of solid state physics. And in this course, we will start with the layer of chips and logic gates. And during our stay at this layer, we will understand the computer storage. We will learn the hardware description language and write HDL programs for different combinational and sequential circuits. Finally, we will design and write HDL for arithmetic logic unit, memory unit, and registers of our target computer called hack computer. Well, hack is the name given by Noam and Shimon, so I will not like to change it. After we are done with this layer, chips and logic gates, we will move up to the microarchitecture layer. The microarchitecture actually defines as how the ALU, registers, memory, I/O devices, and so on are interconnected via buses, and how the control unit moves data in between them. We will design the CPU, which Noam and Shimon have named Hack CPU. We will integrate this CPU with the RAM, ROM, and other I/O devices which we have created in the lower layer to create a full-blown system capable of executing programs written in hack machine language. And above this microarchitecture layer, we have the machine language layer. At this layer, we will design the machine language for the hack CPU. This is also called the instruction set architecture, or ISA. And an ISA is actually the set of registers, instructions, and other features visible to the assembly language programmer. We will design the ISA for our designed hack computer, and some other famous ISAs which you may come across are the x86, ARM, MIPS, and RISC-V. Above the machine language layer, we have the assembly language layer. Dear students, every computer has its own machine language and the corresponding assembly language. To enjoy the luxury of writing programs in assembly language, we need an agent that translate this assembly language to the corresponding machine language. While working on this layer, we will design the hack assembly language and will also write hack assembler in C, which will translate our hack assembly programs to hack machine programs, which will later execute on our designed hack computer. Well, dear students, over here at this layer, we will end up with the pre-mid or the first half of the course, and we will spend our discussion on the design and writing of operating system for the hack computer, and further designing and writing a high-level language and its compiler in some future course. Okay, so now let's talk about the postmid or the second half of the course, whose objective or target is to understand the assembly of x86-64. I think after doing the first half of the course, this will be, inshallah, proved to be a piece of cake for you. Well, dear students, we will start with the history from Intel 4004 to x86-64. Then we will talk about the tool chain. And for this part, the tool chain consists of assembler, linker, loader, and debugger. We will be using the NetWide assembler and GDB with PIDA plugin for writing assembly programs for the x86-64 environment. Then we will talk about the x86 organization, microarchitecture, and instruction set architecture. And of course, then we will start writing basic assembly programs using arithmetic and bitwise instruction, branch and loop instructions, arrays and string instructions for the x86 64-bit processor. Then we will study the process stack and different function calling conventions. We will understand as to how function stack frames are pushed and pop off the stack, and we will talk about the function epilogue and prologue inside the x86 assembly. We will understand the 64-bit C calling convention called System 5 AMD 64 Application Binary Interface. And we will then see how from an assembly program we can call the standard library functions. We will understand the concept of interrupts, traps, and exceptions. We will see how we can call assembly code from within a C program. We will then discuss floating point instruction for data movement, addition, subtraction, multiplication, and division. If time permits, then we will discuss different versions of single instruction stream, multiple data stream, or SIMD extensions of x86-64 architecture. The first is the MMX or multimedia extensions, which were introduced in the Pentium processor in 1993 with 64-bit vector registers. Then we have SSE extensions or streaming SIMD extensions, which were introduced in Pentium 3 in 1999 with 128-bit vector registers. Then we have the AVX extensions, advanced vector extensions, which were introduced in the Intel Sandy Bridge processor in 2008 with 256 bits vector registers. And finally, we will see the importance of understanding assembly in hacking and reverse engineering. Last but not the least, my dear students, don't worry. Don't worry, this outline is not carved on stone. Moreover, just concentrate on learning and understanding new concepts, and grades will run after you. Okay, that is all from my side. Please visit the course Bitbucket repository and download the resources. Do visit arif.me and make it your habit to prepare a summary of lecture notes. This will really help you doing great in exams. And remember, coming to office hours does not mean that you are academically weak. Dear students, Don't worry much seeing the tempo of this introductory lecture. We will build this tower of knowledge brick by brick, inshallah. I wish you all the best, happy learning, and Allah Hafiz.